All right, this is the lesson on graphing logarithmic functions. We're going to be using Desmos to graph them and to see the information that's required, some of our key features. So make sure you have this handout from the substitute and you have a window open with Desmos in it. So like all functions, a logarithmic function does have a parent function. And that parent function is just what we see over here. But we could have a different base. So we're going to say that our parent function will be f of x is equal to log base b of x. And so that will be our parent function, because the base can vary. Now, what we need to understand is when we looked at inverses back in Math 3, we saw that the graphs of two inverse functions are reflections, all right, of one another about the line y equals x. So let's take a look at these two functions in Desmos. So I have f of x is equal to the common log of x, and f of x is equal to 10 raised to the x power. So let's start with f of x is equal to the common log of x. And so we have our graph here, all right? Now, what I'm going to do is instead of sketching that graph, I'm just going to go ahead and copy a picture of it. But you could just get the basic shape down. We're not looking for a masterpiece. We're just trying to get the basic shape down so we can compare. And so I will come back over here and I'll paste that in. And we're going to just put it right here over the graph for log of x. It looks like I'm going to need to make it a little bit smaller. There we go. So here's a graph for the common log of x. All right. Now, for this, what we'll have is we are going to have, we also need a graph for 10 raised to the x power. So let's go back and let's do that one. We're going to turn this one off. We'll leave that one there. So I'm going to have f of x is equal to 10 raised to the x power. And I'm going to do the same thing. I'm just going to go ahead and clip a picture of this one and I'll add it to my notes. You can pause the video and just make a rough sketch of that graph. And we'll come over here and we'll paste this one in as well. And we'll have to make it quite a bit smaller. So here we go. There we go. So we have two graphs. So as I was saying a moment ago, when we have inverse functions of one another, what we'll find is they're actually a reflection about this line y equals x. And so this isn't part of the graph, but as you can see in red, I have the common log of x, or log base 10 of x, and then I also have 10 raised to the x power. And since they're reflections of one another, we know that the domain and range would just switch. All right, they're inverses. So now, it says because you can only graph base 10 logs in your calculator. That is not true. On our calculator, because we're going to use Desmos instead of a calculator, you don't need to make the inverse exponential function. So you can ignore this note right here. All right? So what we're going to do is just practice here. We're going to do a few of these, graph each function, identify its key characteristics. And we'll just review what each one is, and we'll talk about how each one works. So this first one is just a graph f of x equals log base 2 of x. So I'm going to go ahead and get rid of these other things here. And so that note was telling us we'd have to do the inverse function first and then invert the x's and the y's. We don't need to do that since we're using Desmos. So we've got y equals log base 2. Remember, to get the base in, you can just hold down the shift key and press the dash key up by the plus sign. Then you just have to remember to press the right arrow key to come out of the base. So here is log base 2 of x. Now, if you're graphing this by hand, because obviously you're not going to be able just to capture a graph, a picture of the graph, what you can do to help you graph it is go ahead like we did in some of our other problems. We'll just turn it into a table. All right? We'll turn it into a table. And so remember, we've talked about how we cannot take the logarithm of anything that turns out to be 0 or negative. It always has to be a positive value. Well, that's what's happening here because we have x. And so that's why it's saying undefined, undefined, undefined. because we're giving it values of x that when I finish simplifying it, in this case there is no simplifying, I'm taking the logarithm of something that I cannot use. It's undefined. So if you wanted some more points to graph, you could do 3, 4, 5, 6, 7, 8, and that's probably enough. Now, these decimals, you could try and approximate them, or you could just go with 0, 1, 2, and 3. But what we have to realize is that when we look at this thing, we know there are still positive numbers between 0 and 1. So for instance, up here, I could come in and I could put in, let's see, let me hit enter. Whoops. Let's get the 1 down here. We'll go back. We'll put in 1/2. I'll go back up here. Let's press enter again. Maybe? Oh, it opens it up down there. So I could put in 1/2, for instance. I'll go modify this one. 1/4. There we go. And so you can see there's other points along here. And this thing is going to approach 0, x being 0, but it's not going to reach it. And so that's going to bring back one of these key features we have to do. So I'm going to go ahead and just take a screen capture, go ahead and pause the video, use some of these values here to graph this on your handout. Now, we will not be asking you to graph these by hand on an assessment, but I want you to get familiar with how a a logarithmic function works for graphing. All right, how does it work? So when I have a base greater than 1, right, if the base is greater than 1, so I'm going to make some notes here. If the base is greater than 1, let's see, the graph will approach, let's make it so it doesn't go over the graph. The graph will drop to -infinity. Okay. As x approaches 0. That's one fact of it. And also, if the base is greater than 1, the graph will approach positive infinity, okay, or just infinity, as x approaches positive infinity. Right? So we have x approaching 0 and x approaching positive infinity. Now, as x approaches positive infinity, the graph will approach positive infinity, and I'm going to add something in here, very slowly. Okay? So this thing never quite levels off, but it also doesn't grow really, really fast. So if we come back to Desmos, we can see it's leveling off, and it's growing slower and slower. It's still growing, but it's going to get slower and slower and slower. All right? So it's still going to positive infinity as x goes to positive infinity. But as x goes towards 0, it becomes negative infinity. All right? And so we can just use those points from Desmos to graph this thing. Now, let's talk about domain and range. All right? You may recall domain is a set of all x values such that we can get a y value from the function. In other words, if there's anywhere where I'm going to end up causing it to become imaginary or undefined, then I can't include that in my domain. So as we saw here in Desmos, I can put in 1/2, 1/4. I could even put in 1/8, 1/16, 1/32, 1/64. I can get smaller and smaller and smaller. I could put in 1/1000th, 1/1,000,000th, 1/1,000,000,000th, and everything. There would be a y value associated to it. The first place where it's undefined is when the argument of the logarithm becomes 0. All right, now that may not always happen at 0. It might not happen until -2 due to transformations. We'll see some in a bit. But so my domain here for this equation, my domain is going to be from 0, because it can't be 0, so we're using a parenthesis, can't include 0, and it's going to be this way until positive infinity. Okay, that's going to be my domain, positive infinity. So it can go to the 0 to the left, see like it's coming into 0 here, and as I go to the right, it's going to go to positive infinity along the x-axis. Now the range, on the other hand, since this thing drops to negative infinity as x goes to 0, the range, remember, is all those y outputs, or the output values. So this thing will start down at negative infinity. I start typing inputs. Infinity, there we go. And we said as it goes to the right, it keeps on growing. So it's going to go ahead and go on to positive infinity. And there we go. There's our domain and our range. And so this is going to help us with our end behavior, because if you notice, it tells us f of x goes to positive infinity, f of x goes to negative infinity. It's going to do one of those two things. Now what we need to know is which one does which. And an easy way to see that is what I'm looking at here is notice where it goes to positive infinity in the range. That's this f of x part. So let's highlight those. So I'm going to come back and I'm going to highlight those. So when I look at this in my range here, and I see that positive infinity, this is the same thing we're talking about. And that's going to correspond to my, that's what it's talking about. So what I have to look at is, well, which x direction was this happening? Where was this thing going off to positive infinity in the y direction? So we're looking at, does it go to the left or go to the right? When does it keep going up? And so it shows that it keeps going up as x is getting bigger. So we're going to come back over here and record, well, f of x is going to go to positive infinity as x goes to positive infinity as well. Now that's not always going to be the case. Sometimes this thing is going to reflect and do just the opposite. But for right now, we're going to say as x goes to infinity. Now this negative infinity piece also ties to part of my domain. All right, the negative infinity piece here tells to part of my domain. And we see that it happens right up here. So it's for my range. It's going from negative infinity to positive infinity. All right. And so what I've got to look at is, okay, so when is this thing dropping to negative infinity? For what x values? And it says x gets closer and closer and closer to this y-axis. So that means as x goes to 0. So we're going to put in here as x goes to 0, f of x goes to negative infinity. Now, another thing that's of interest to us is our x-intercept. All right. Remember, intercepts are always points, and you should always list them as such. If I go to my x-intercept here, it looks like I have an intercept at about 1, 0, because there's 2, there's 0. Halfway between it would be 1, so I'm going to say I have a x-intercept rather at 1, 0. And now the time for the thing that we saw back in Math 3 when we did rational functions. It's our asymptote. And so we saw vertical asymptotes with our rational functions. They also occur with logarithmic functions. And so remember, an asymptote really is kind of an imaginary line. It's like a boundary that the graph is going to approach. And it's going to approach it. And so what we have here is we have a vertical line that this thing is going to approach. And when it's a vertical line, we're always going to express it as x equals. Okay, because it's a vertical line, it's going to be x equals. If it was a horizontal asymptote, like you probably saw in Math 3, then we'd label it as y equals. But these are always going to be x equals because it's always going to be a vertical. And we're going to list that x value. So what is that limit on x? Well, it's 0. So my asymptote is going to be at x equals 0. And that's it for number 1. All right. So let's take a look at one when our base is not greater than 1. All right. So let's take a look at number 2 here. We've got log base 1/3. All right. Let's see how that changes things. So let's go ahead and go over here to graph it. We're going to get rid of this one, and we're going to put in y equals log, using that shift dash key again. We'll put in 1/3, and then I got to remember to come out of the base, and then we have x. Oh, okay. Well, that's interesting. Instead of going to negative infinity here, it's shooting up to positive infinity as x goes to 0. All right, so we're going to take these notes here, and basically we're going to modify them. And so now we're going to say if the base is between 0 and 1, because that's what this is, 1/3 is between 0 and 1, the graph will shoot up to, and let me fit this in here so it's not going over the graph, it will shoot up to positive infinity as x, whoops, let's get out of that. There we go, as x approaches 0. And then we can see from the graph here in Desmos on the other end, as x goes to positive infinity, this thing keeps going down. And so this time it's going down to negative infinity. All right. So if the base is between 0 and 1, the graph will will decrease towards negative infinity very slowly as x approaches positive infinity. So in other words, as x goes to the right, what's going to happen is that this thing is going to keep decreasing. It's going to happen very slowly over time, but it is going to negative infinity. So let's go back and talk about our domain. And we're going to start talking about the key features here, or the characteristics. So notice my domain, I still can't take, and let's even make the table for it. Here we go. I still can't take the logarithm of a negative number. All right, so I can't take the logarithm of a negative number. So I can see at 0 it was still undefined. So I could do like 1/8, 1/4, 1/2. And then we could come down and do some more of them. We could come down here and do 3, 4, 5, 6, 7, 8. And let's do 9. Why not? All right. So I can see that it's undefined at 0, but even when I make fractions that are between 0 and 1, I still have a y value. So again, the domain is still going to be from 0 to positive infinity. All right, from 0 to positive infinity. The range, if I look at how low this thing goes, it's still coming in from negative infinity. It's still, or at least on one side, it still goes to negative infinity, if you want to put it that way. So that always gets listed first, because if you have something going to negative infinity, that's the smallest it can go. And then as x goes to 0, we see it shoot up to positive infinity. So if you notice here, these two didn't change just by changing the base. So anytime if the only thing is changing the base, then the domain and range are not going to change. All right, they're not going to change. So let me go ahead and get a copy of this graph in here. Let's see. We'll go like this. Again, you can use this table to graph it on your paper. I'm just not going to do that right now because it would be awfully boring sitting here watching me graph something by hand. So I'll make that one a little bit bigger. So here's the graph of log base 1/3 of x. All right. So we've got our domain, our range. So I still have positive infinity, negative infinity. Well, let's look at which way is it. When is it going to positive infinity? Well, as we sit over here, as x, if the base is between 0 and 1, the graph will shoot up to positive as x approaches 0. So we're going to say as x approaches 0. So we've got 0 there. And then f of x going to negative infinity. Well, that happens as this thing, as x goes in the positive direction. So as x approaches infinity, it slowly goes to negative infinity. So we're going to come in here, we're just going to put in a positive infinity symbol. All right. So as x goes to positive infinity, in this case, when the base is between 0 and 1, the function is going to go towards negative infinity. Now, something else that's not going to change because of the base, notice again, what is my x-intercept? Right? In number 1, I had a base of 2. Here I have a base of 1/3. My x-intercept is still 1, 0. That's still 1, 0. And in fact, my asymptote has not changed. Because this thing, as x approaches 0, it shoots off to positive infinity. My asymptote, my vertical asymptote that is, because that's what a logarithmic function is always going to have, is going to be x equals 0. All right. So with that, you should be able to continue working with these, graph it in Desmos, determine the domain and range, in behavior, all that stuff, x-intercept, asymptote. And I will be posting the answers to this, all right, in Canvas. Once you've got that, what I would like you to do is come back to your Delta Math. And let's see, let's log in here. There are some problems with graphing, all right, in the Unit 3 Delta Math. Unlike yesterday's lesson with the applications, there weren't any of those in Delta Math. So let's take a look. What do we have here? Oops. Don't need to manage you all. Let's go to sample student page. That's what I was trying to do. So we'll go to second blocks. And so you'll see that next skill is graphing exponential and log functions. And so I believe what they've done is they've removed the exponential, and so they're just going to have us graph the log functions. So this is one of the ones where you're going to have to move these yellow points to match what the log function is. Now here's a tip. Go in, right, and graph this in Desmos. So I have log base 3 of the quantity x minus 4. So let's go in here. So I've got y equals log base 3 of the quantity x minus 4. So there we go. Here's what our graph should look like. And in fact, I can even get a table of values. I can come in and get a table. And notice here, it's undefined all the way up to 2. It's going to be even undefined past that. Okay. And here's why. It's undefined all the way up to 4, because 4 minus 4 would give us 0. All right, 4 minus 4 would give us 0. Oh, and I think there was a negative in there as well. So let's make it negative. And all that's going to do is make all of my points reflect about the x-axis. All right, all my y values are going to be negative now. And so you can get some extra points here. You could even keep going. You got 12, 13, 14. We'll eventually get to negative 3. There it is at 31. All right. So you could use these points. Not super useful when I get to 31, but you could use it. All right. To get that graph. And so now what I can do is come in here and look at where my y-intercept is, where my x-intercept is. All right. So it wants to know where the asymptote is. Well, it's going to be a vertical asymptote. And I can see that vertical asymptote is going to be at x equals 4. So I'll come in and drag the x-asymptote into x equals 4. And now what I need to do is start putting my values in here. So like for instance, I can see, whoops, wrong tab. I can see that my x-intercept is going to be at 5, 0. So I'm going to drag this one over here to 5, 0. And notice my line disappeared. It's because this one is over here. So what we're going to need to do is give it another point. So let's see, where can I do? Oh, show all 23 rows. Let's go to 7, -1 with that one. So over to 7, -1. There's another point. I'll submit my answer. And there we go. Okay. And so now we have our graph of our logarithmic function. Next problem. Okay, I've got log base 2 of x minus 1. It is going to have a vertical asymptote. All right. And for this one, I know its vertical asymptote is going to be at x equals 0. So I'm going to put it right there on the y-axis. I know my x-intercept is still, I believe my x-intercept at least is still going to be, oh, it might not be. Let's go take a look at graph. Let's not guess. Let's graph it. And so I don't have a negative in front of this one, but I have log base 2 it was, and then x of x minus 1. And so notice here I'm not putting parentheses around it, because in this one the logarithm's only of x, and then we're subtracting 1. All right? So let's see. Yep, so that's what I thought. My x-intercept has changed to 2, 0, because everything's been shifted down 1. This would have been my original x-intercept there, but everything's moved down. We're going to talk transformations tomorrow when I get back. All right? So we've got that asymptote. This has been moved to 2, 0. Let's pick another point. Let's go here. Let's find a table of values, eh? So I've got 1, negative 1. Let's see if I can get something else as well. I've got 4, 1. I've got 8, 2. So let's come back. Let's use 4, 1. So I'm going to come over 4 and 1. Drop it right there. So I've got my x-intercept of 2, 0. I've also got the secondary point at 4, 1. I've put my vertical asymptote at x equals 0. Let's see what it does. And there we go. So that shows you how to fill out these notes. You should be able to do these, graph each one, get those key features, all right? And then you should be able to complete this skill in Delta Math. So remember, by the time you finish this, you should only have one more skill left, which is logarithmic regressions, all right? Logarithmic regressions. And I'll answer any questions from applications, these graphs, and everything tomorrow when I get back. Until then, have a great day, folks.